develop a more graphical approach kaya nabuo si Mohr circle. So to give you an idea, it was developed in the 1800s, close to 1900s. So ganun kaaga. Kaya kailangan nila ng graphical solution. Kaya sumikat yung method ni Mohr, the German engineer Otto Mohr, kasi it is simplistic in a way that he was able to prove that the equation for stress transformation are just can be analyzed as the equation of a circle. So para kang merong x minus h squared plus y minus k squared equals r squared. So ganun yung naging itsura ng equation if you plot sigma x prime and tau x prime. So that is the equation of a circle centered at C and 0 kasi walang constant dito. So C is the sigma average, let's remember that from last meeting, and then R is the square root of a squared plus b squared. So kaya mas naging madali sa kanila dahil mas kaya nilang mag-solve ng ganito kaysa mag-trigonometric identities. Okay? So, Mohr circle basically represents each orientation. So, ibig sabihin, bawat point on the circle represents a certain orientation from the original plane. So, if you have theta in real life, that corresponds to 2 theta in the Mohr circle because if you remember the stress transformation equations, they're in terms of sine 2 theta at cosine 2 theta. Kaya talagang double yung angle dito sa Mohr circle. Now, the sign convention is as follows. First, for sigma, it's tensile positive pa rin, so walang problema dyan. Tau is a bit more tricky. So, in some references, you will see sigma x prime to be like this, pero yung tau x prime is plotted positive downwards. Ang nangyayari doon, kapag positive downwards, baliktad lang. Counterclockwise yung positive rotation. So, para hindi nakakalito, para pare-pareho tayo, so we will use tau x prime y prime na positive upwards, pero from the state of stress like this, you will be able to know if it plots upward if it causes a clockwise rotation. So, clockwise, pag ganyan, so magiging point upwards. Kapag counter, it's below the horizontal axis. So, to help you practice, for example, this tau x prime y prime, the rotation it causes about this plane is actually counterclockwise. Pag ganun, di ba? Therefore, it plots as negative. So, ito po siya, yung point na yan. So, for example, ito naman, tau xy. So, this one causes clockwise rotation. So, pa-plot yan above. So, for the Mohr circle, it's actually each plane. So, itong plane na to, may point sa circle yan. Itong plane na to, may point sa circle. And then, itong plane na to, may point din sa circle. So, ganun yung pag-understand ng Mohr circle. Each point on the circle represents a plane of the state of stress of an element. Okay? Now, we can also determine the principal stress in plane using the Mohr circle. So, the orientation of the principal plane, so remember, ito yung mga na-compute natin na equations, pero yung pag-visualize sa kanya sa Mohr circle, so remember, principal stresses are the maximum and the minimum normal stress. Kung ito yung circle mo, yung maximum sigma will happen here, and then your minimum sigma will happen here. So, pretend ko lang po ng laser para mas madali makita. So, ito. Dito is sigma P1 and this one is sigma P2. Okay? Now, remember, your principal orientation, theta P, is measured from the x-axis or the vertical plane. So, recap lang natin na vertical plane is the x-axis, horizontal plane is the y-axis. So, if in real life, to get to the principal orientation, you get theta P, ganyan, so na counterclockwise, in the Mohr circle, so for example, ito si point x, paano nalaman na yan si point x? So, sigma x, yung kanyang sigma, and then yung tau niya, tau xy, causes counterclockwise. So, sa baba yan. So, ito po yan, point x, sigma x, and negative tau xy. Okay? So, if you rotate by 2 theta p, you should be able to go to the principal stress. So, kung theta p dito, 2 theta p naman dito. Now, paano malalaman yung kabilang principal orientation? So, remember, pinag-usapan natin, para makuha si theta P2, kapag alam mo na si theta P1, use either add 90 or deduct 90. So, kung sa Mohr circle, that just corresponds to either plus 180 or minus 180. So, kunyari, ito, 2 theta P, so ito na yung theta P1. So, you either plus 190, so plus 180 dito yun. So, pag ganito, pupunta ka pa rin dyan. or minus 180. So, pag ganyan naman. So, pareho lang, di ba? Nakakalabasan na plane. Kaya nga siya, you can choose either to add or to deduct. 90 degrees sa theta P or 180 sa 2 theta P. So, ganun po yung pag-plot. Now, how about point Y? So, again, point Y is the horizontal plane or the Y-axis. So, you plot sigma Y, and then tau xy. Now, in this plane, tau xy causes clockwise rotation. So, nasa taas siya. Kaya ito yung pinaplot niya. Point Y is sigma Y tau xy. Now, if you connect these two, in real life, they are 90 degrees apart. Therefore, in the Mohr circle, they are 180 degrees apart. So, they already form your diameter of your Mohr circle. So, if you know the center, you know the diameter, you can form the whole circle. Okay? Now, how about these two others? Ito po ba, sir, ibang point pa ito? So, tingnan natin, ano ba yung value nito? Sigma x, di ba? Ito, tau xy na counterclockwise din. So, sigma x, negative tau xy, ito rin siya. Same point. Kasi 180 degrees apart ito in real life, 360 degrees apart yan sa Mohr circle. So, pareho lang. Same with between these two, between this pair. Itong top face sa bottom face. Okay? So, ganun po siya sa pag-plot. So, remember, Mohr circle, each point is a face or is a plane on the orientation of the state of stress. Now, you can also find the maximum shear stress in plane. So, ito po yung orientation na nasolve natin and then the values. So, remember, your tau max in plane is just the radius. Bakit nagkaganon? If this is your Mohr circle, the maximum value of tau is actually this one, yung pinakamataas, di ba? And the minimum value is ito naman. So, this represents the radius of the circle. So, kaya tau max can be positive or negative. Yan, meron tau. Plus and minus dahil nga square root siya. Now, you also have to note that if this is your principal plane, kasi nandyan yung sigma p, in the Mohr circle, they are 90 degrees apart kung saan yung theta s or yung plane of maximum shear stress. Sabi natin kasi, in real life, they are 45 degrees apart. Kaya sa Mohr circle, 90 degrees apart sila. Okay? Now, aside from the planar state of stress, you can actually plot the general state of stress, which corresponds to 6 phases, or simply 3 planes. Bakit 3 planes lang? Kasi, itong plane na to, for example, yung nasa harap, is the same dun sa nasa likod. Yun yung pinakita natin kanina, di ba? Yung katapat niya, same point lang sa Mohr circle. Ito naman taas, same dun sa nasa baba. And then itong nasa left, same dun sa nasa likod. So kaya, basically, meron 3 planes na pinaplot. Now, if they are all subjected to only normal stresses, it's called the triaxial state of stress. So triaxial, ibig sabihin, tatlong normal stress lang, walang shear. Now, by definition, we showed that kapag wala kang shear dun sa plane, that is already your principal plane. So, actually, ang principal stresses, hindi lang sa sigma P1 at sigma P2. Meron pang sigma P3 nandun sa pangatlong axis. Kaya meron kang sigma A, sigma B, sigma C. So, in our case lang kasi, for ES102, we mostly deal with planar states of stress such that your third principal stress, yung sigma 3 or sigma P3, is either towards you or away from you. And it's equal to 0 for planar states of stress. Kaya hindi siya nakikita. So, pero in real life, you can have 3 principal stresses. Now, for our case, principal state of stress lang. So, ganyan, sigma 1, sigma 2 lang. Wala yung sigma 3 na nandito sa Z. We can actually look from 3 perspectives. So, first, we look at it from the XY plane. So, sabihin, top view. So, makikita natin si sigma 1 papunta kay X. So, ito yun. And then, si sigma 2 papunta kay Y. So, ito naman yan. Okay? So, top view po yan. Now, we can also view this from the XZ plane. So, sabihin dito, parang front view. Hindi natin makikita si sigma 2. Makikita lang natin si sigma 1 na papunta kay X. So, ito yun. Tapos, walang laman yung papunta kay Z. So, ito naman yan. So, yan naman yung itsura ng state of stress na to in the XZ plane. And then, in the YZ plane, hindi naman natin makikita si sigma 1. Kita naman natin si sigma 2 papunta kay Y. Yan. And then, wala dito sa papunta kay Z. So, ibig sabihin pala, each state of stress, even if it's planar, you can actually view it from 3 planes. And each plane has its own Mohr circle to represent all the orientations within this plane. Kasi for example, XY plane, pwede mong ikot-ikutin yan, di ba? Pag ganito yung box, iikot siya, iba-iba yung state of stress. Ay, iba-iba yung, states of stress ng orientation na yun. Now, in the XZ plane, pwede mo rin ikot-ikutin yan, same for YZ. So, meron kang kanya-kanyang Mohr circle for each plane. Kaya nagkakaroon ka ngayon ng concept ng absolute maximum shear stress. Why? Kasi ang nasusolve lang natin earlier is just the maximum shear stress in that plane, in plane. Eh sabi nga natin, merong 3 planes for each state of stress. So kung meron kang 3 planes, in theory, meron kang tatlong maximum shear stresses in plane. Kasi nga tatlong plane. Now, among the 3, merong pinakamalaki yung magnitude. Yun yung absolute maximum shear stress. So ulit ha, each plane, meron kang tau max in plane. And then, among the 3, there's one that has the largest magnitude, and that's what we call the absolute maximum shear stress. So to help illustrate that, we first look at the first case wherein you have the same signs for the principal stresses, sigma P1 and sigma P2. Kanyari, ganyan, same sign, pareho silang tensile. So remember, sigma P1 is, in our convention, is on the right of sigma P2. So kapag piningin natin siya from the XY plane, ito itsura niya. Ito po nasa left. In XZ plane, hindi natin kita yung sigma 2 kasi papunta siya kay Y-axis. E di ba yung Y-axis in this case, kapag ito yung XZ, papunta sa inyo. Out of the page, kaya hindi kita si sigma 2. And then kapag tinignan naman natin si YZ plane naman, YZ, yung x-axis naman dito, papunta naman ulit sa inyo, so out of the page pa din. So, hindi natin kita itong sigma 1. Ang kita lang natin yung sigma 2 towards y. So, sigma 2 towards y, sigma 2 towards y. Okay? So, ito yung tatlong itsura kapag same sign si principal. Now, we can make, again, separate more circles. So, unahin natin, ito yung itsura ng tatlo. So, dito muna tayo sa xy plane. So, kung ito yung principal stresses, sigma 1 and sigma 2, so meron kang sigma 1 na sa pinaka-right, sigma 2 na sa pinaka-left. So, therefore, you draw this circle. Ito nga yung circle na to corresponds to the xy plane. Now, in this plane, the xy plane, you have the radius of this circle, and that is your tau max in plane in the xy plane. So, sa XY plane, meron kang tau X prime Y prime na max. So, siya yung maximum in-plane shear stress. Okay, ito po yung Mohr circle for this one. Now, for the YZ naman, itong YZ, ang kita lang natin is sigma 2, and then the other principal stress is 0. So, sigma 2 and 0. So, ito naman siya, itong circle na to, nasa left-hand side. So, this circle corresponds to the XZ plane. Tapos meron din siyang sariling tau maximum in plane. Kaya merong tau y prime z prime max. Lastly, kay xz plane, ang kita natin is sigma 1 and 0. So sigma 1 and 0. So therefore, you have this Mohr circle, yung malaki, which corresponds to the Mohr circle for the stresses in the xz plane, itong malaki. So again, meron siyang sariling maximum shear stress in plane. Let's call that tau xz prime max. Now, you compare among the three, xz prime, xy prime, and yz prime. Ang pinakamalaki dyan would be the range of the biggest circle. So therefore, ito yung absolute maximum shear stress. So this is an example wherein you have principal stresses that have same sign. Ang nangyayari, yung tau max in plane, which is tau x prime y prime, is not equal to the absolute maximum shear stress. So kapag same sign sila, laging mas malaki si absolute kesa kay maximum in plane. Okay? So po kayo malilito ha, parang ang main plane natin is xy kasi nandun yung dalawang dalawang normal stresses, sigma 1 and sigma 2. So yung tau max in plane nun is tau xy prime, pero hindi siya yung absolute maximum. Lumalabas yung absolute maximum is this one, tau xz. Kung nasaan si sigma 1. Okay? Si sigma 2 kasi mas maliit kesa kay sigma 1. So, how do we find this value? Tau x prime y prime z, or the absolute maximum shear stress. So, radius siya nung malaking circle. So, how do you find the radius of the big circle? Remember, this is 0, this is sigma 1. Therefore, itong radius from the distance from 0 to sigma 1 is just your diameter. You take the half, you get the radius. So, for same signs, it's equal to sigma p 1 over 2. Now, kapag parehong negative naman, si sigma 1 saka si sigma 2, so yung Mohr circle mo nandito sa left. Diba? So, instead of sigma P1, sigma P2 yan. Kasi sigma P2 yung nasa pinakakaliwa. Okay? So, yun naman yung Mohr circle niya. Now, how about the other case? If the principal stresses have opposite signs. So, they have opposite signs, something like this, sigma 1 and sigma 2. So, tensile and compressive. So, again, pag tingnan natin sa XZ plane, ganito yung itsura. Hindi natin makikita si sigma 2 kasi into the page naman siya. And then sa YZ plane naman, hindi naman natin kita si sigma 1 kasi out of the page naman siya. So again, meron kang tatlong planes. You have 3 separate Mohr circles. So ito yung tatlong yon. Unahin natin itong XY plane, ha? So meron kang sigma 1 na positive, sigma 2 na negative. So sigma 1 na positive, sigma 2 na negative. You connect them, you get a circle. So, itong malaking circle that corresponds to your XY plane. Ito namang left, sigma 2 and 0 yung kanyang principal stresses. Sigma 2 and 0. So, ito yun, di ba? YZ plane. Sigma 2 na compressive, so negative, and 0. Lastly, itong XZ plane, meron kong sigma 1 and 0. Sigma 1 and 0. So, ito naman siyang circle na to. So, again, each circle has its own maximum shear stress. Tau YZ prime, tau XZ prime, and tau XY prime. Now, again, our main plane is the XY. So, yun yung maximum shear stress in plane ng XY. Pero nagkakataon na kapag opposite sign sila, same yung maximum in plane saka absolute maximum shear stress. So, kanina nakita natin na kapag same signs, laging mas malaki si tau abs max or maximum shear stress, absolute maximum shear stress, kumpara kay tau max in plane or the XY. Pero kapag opposite sign, equal sila. Ulit ha, pag same sign, mas malaki dapat si tau abs max kaysa kay tau max in plane. Kapag opposite signs naman yung principal stresses, equal sila. Now, lastly, how do we find this distance? E di ko ito yung buong circle, the diameter would be this distance, sigma 2, plus this distance, sigma 1. So para maging distance, kukunin lang natin yung absolute values, and then we divide by 2 kasi yun yung radius. Kasi itong sum would be the diameter. Okay? So that is your tau abs max.